Okay, I have to, oh my God, what did this man do to my chair? It's like on the ground, and then the things keep moving. I don't know. All right. Anyway, so I just have to show you how to do standard form of a parabola. I think you guys are going to think it's pretty easy, but the difference between a circle and a parabola. So you can see the circle has an x squared and a y squared. Because we had two squared terms, we had to complete the square twice. A parabola only has one squared term, so you're only going to complete the square with either x or y, depending on whichever one's squared. But look at this side of the equation. There's factoring happening here. Anybody know what it's called? What type of factoring is happening on this side of the equation?
FOIL.
Close. FOIL's when there's two parentheses, though. There's only one. What'd you say? GCF. Okay, so what we're going to do is we're going to complete the square with either x or y, and then for the other variable, we're just going to factor out a GCF, and then that's how it's going to become a parabola. So like this side will be complete the square, and this side will be GCF. So you're doing two different types of factoring, both of which you know how to do. Okay, so we're going to manipulate the equation so that it looks like that. So in your toolkit on page 3, there's this example, and it says, use the complete the square method to write the parabola in standard form. So here's why I know this is a parabola. See how there's only x squared? No y squared in sight. Okay, is this not on page 3? 4? Is 4 a better guess?
Yes, 4.
All right, 4. Thank you. Alright, so on page 4. So, I know this is a parabola. Parabola is the only one of the 4 shapes you're going to see that has one squared term. So, if this had an x squared and a y squared, you would make it a circle. You'd complete the square twice and put it in circle format. But because there's only one squared term, we're going to complete the square once and we're going to GCF once. So, if x is the squared term, you're going to keep the x stuff on this side of the equation. And we're going to complete the square for the x. So I'm going to put a plus blank for that. And then what I'm going to do is move the y and the other term to the other side. Normally we just move the 32, right? Because we'd be completing the square with the y as well. Because we're not completing the square with the y, we're going to move that too. If you look at the standard form, if you look at all of your parabolas, x's are on one side, y's are on the other. They're on different sides for a parabola. So I'm going to move the 16y to this side. And to do that, I'm going to plus 16y. And I'm going to move the minus 32 to this side. And to do that, I'm going to add 32. So I'm doing opposite operations to bring it over there. But I'm also going to do this. Because I can't add something to one side of the equation that's not there without adding it to the other side as well. So I've got to do that number over there too. So complete the square. Happens the same way we do it for circles. It's half of this number, -4, squared, 16. So the number I'm adding in, my perfect square is 16. So I'm going to add that to both sides. On this side, I can factor it now. So what multiplies to 16 and adds to -8? Well, that's -4 and -4. Or I'm just splitting that number in half. Remember, we bring the sign down and divide that number by 2 and square. Just like we do for circles, we're doing the same thing here. On this side, I'm going to combine my like terms. So I end up with 48. So remember, to make it look like a parabola, you need that 4p term. And that's in front of a set of parentheses. So I am going to GCF this second side. So I'm going to divide out the common factor between 16 and 48. Typically your GCF is whatever number is in front of the y. Okay, so like I'd say mostly all the time. So my GCF here is 16. Okay, and I'm going to divide a 16 out of each of these things. So if I divide a 16 out of 48, I get a 3. This is the standard form of a parabola. Right now we have something squared on one side and then a GCF on the other. So we've used the complete the square method to find the standard form of a parabola. Now the vertex is opposite of what's with x, opposite of what's with y. I can read that from that standard form. It opens, well, we talked about yesterday, if x is squared, then it's going to open up or down. So it's like the u or the upside down u. So it's going to be one of those. And because the coefficient on this side is positive, it's going to open in the positive direction. So this is going to open up. And then we know that this number right here, this 16, is in the 4p spot. So if I want to solve for p, I would just divide that number by 4. I'd be doing like 4p is in the same spot as 16. So p is 4. So your radius in the up and down direction is 4. So you'd go up 4 to make the focus and down 4 to make the directrix. Easy enough? The trick is just making sure you know which one you're completing the square for. So this second example, you can see it's definitely a parabola because there's only a y squared, there's not an x squared. If there was an x squared, you'd want to make it a circle, okay? So it's a parabola, and since the y is being squared, I'm going to keep the y terms on the left. So we've got a y squared and we've got a minus 4y. So I'm going to complete the square with y for this one. And then I'll move the x's to the other side. So there's a positive 10x on the left. So to move it to the right, I would subtract 10x. And there's a positive 64 on the left. So it would become a negative 64 on the right. So for a parabola, you have to separate the x's and the y's. Put them on different sides of the equation. I'm also going to add a blank here. Because whatever I complete the square with on the left, I've got to add that number to the right. So what's my perfect square for this one? What's my perfect square for that line? 4. Yep, 4 is the number I'm going to add to each side. So factored form here would be y. I'm going to bring down the minus, and then half of that number is 2. So it's y minus 2 squared. And on this side, when I combine my like terms, negative 64 plus 4 is negative 60. Almost looks like a parabola, but a parabola has parentheses on this side too. So now I just have to do the GCF. The GCF between negative 10x and negative 60 is a negative 10. So I can divide the negative 10 out of each of those. And I end up with x plus 6. So this is the standard form of the parabola. Now for this parabola, because it's y squared, it's either going to be left or right. And then because the coefficient's negative, it'll go in the negative direction. This one's going to open left. With the center at opposite of x, negative 6, opposite of y, positive 2. The p for this one's a little funky because what's in the p spot is a 10. We talked about yesterday how you can make the p negative. It's not a big deal if you do, but p really is just giving us direction. So, or sorry, the negative is just giving us direction, so we don't really have to include that. So I'm just really looking at the 10 when I'm setting it equal to the 4p. So if I divide both sides by 4, I get 2.5 for that. So my radius to the left and right is 2.5. I'm going to go left and right because of the way it opens. Whereas the other one, my radius was an up and down radius. You okay with that? Do you guys want to see one more? Feel okay? I'm happy to do one more if you want to see it. But all right, so I want to give you the rest of time today to work on practice for that quiz. There is a typo and it won't The GCF won't work out nicely if you don't change it, and I wanted the GCF to work out nicely. So on page 8 of your quiz review guide, letter E has a plus 46, but you're going to make it a plus 44 instead. So on tomorrow's quiz, you are going to have to graph a circle. So I'll give you a circle in standard form. You'll tell me the H and the K, the center, and then you'll tell me the radius, and you'll graph the radius in all directions and make a circle. You'll have to graph a parabola, so you'll have to tell me the H and the K, the P, the 4P, so the focal length, the focal width, the focus, and the directrix, and be able to graph that. And then you'll have to complete the square for both a circle and a parabola. So manipulate an equation to make it look like the circle standard form and a parabola standard form. Questions for me? All right, you have the rest of class to work on the review guide, which is 7 and 8. Just make sure you change this. And then also, I have you in here for bonus block tomorrow. I made a practice quiz up. So I'll give you that. You can do the practice quiz right before the quiz. And then that way the quiz should go really quickly. If you want me to sit with you for any of these, let me know. Nothing's with the Y, so you're going to make it a 0. All right, so plot the vertex first. It's easy to see it. So go 1, 0. Now, one thing that this doesn't say is the way it is. Would you say this is up, down, left, or right? It's up, right? So what you're going to do is you're going to go from that point up. That's the coordinate. Oh, it's a coordinate. And then from your center again, go back to your center. Go down 30. Now, instead of making a point there, make a point there, but when you fill in the directrix, it's not a point, it's a line that way. And it's a y equals when it's sideways, so that will be y equals what, -3? Is that where you're at?
Yeah.
Yep.
Okay, and how do I graph?
So from your focus, the only thing you didn't use yet is this width. So from your focus, you want it to be 12 wide, so you're gonna go 6 in each direction to make it like even.
Do you count this one?
Nope, go like 1, 2, 3, 4, 5, 6, make a point, and then the other way. Make a point. So your vertex will go through those two, and that'll be your U shape. Yep, there you go.
Okay, thank you.
That's it.
Can I still phone?
Sure. Yes.
Also, the Monday, I'm pretty sure when we get back from break, I'm not gonna be here, so I have to like, no, I'm seeing you like at college, because that wasn't, excuse, because it's for